Okay, so 1.5 is about postulates and theorems. Hey guys, who remembers? We actually talked about postulates. What are postulates? Raise your hand if you remember. Let's see. Anybody? It's always same people. Come on, some other people. Okay, you guys show. How about How about Johan? Johan, what do you think? Do you remember? We talked about postulates before. These are statements that we
follow.
Yeah.
Just for no reason.
For no reason. It's not for no reason. We just accept them as truth, right? Some of the postulates we learned. Who remembers? Abel?
The angle addition postulate.
Angle addition postulate. Sure. Some other ones we learned. How about Nor? The protractor postulate. Some other postulate we took them without actually proving. Emily? We said angle addition postulate. Do the other one. If you have angle addition, what do we have before that one? Something addition postulate.
Line segment.
Yeah, line segment addition postulate. We just call it segment addition. Okay, and what else? Okay, how about Charlie? Ruler postulate. You guys remember we had 4 postulates that we studied, right? We learned, we know what they mean, that we take them as truth. Oh, do you think we have one more, Joseph? Joseph, did you want to say something about it? Oh, okay.
Postulate number 4. That's a postulate.
Oh, we're not supposed to memorize them as like postulate whatever number, okay? We're supposed to either by names, or if they don't have any names, you have to actually know what they are. So far, all the postulates, they had names. Isn't that nice? Now, what again, anybody want to guess? If the postulates are statements that we take them without proving, what are then theorems? Anybody know what the theorems are? What do you think these are? Lara? Yeah, so we don't know if there's truth. These are statements that we actually need to prove. These are true statements. Yeah, so these are theorems that we have to actually prove and understand. You're exactly right. So, we're going to learn another postulate. Okay, this one does not have any name. Guess what? You have to actually
Write it down.
memorize. Okay, so exactly right.
We have to write all of it?
Yes. And it's not that long. So, watch this. And hopefully it makes sense to us. But when we, okay, so postulate, so by the way, like I said, the postulate, whatever number isn't important. Okay, that's not the important part. It's the actual, the statement is important. You have to know. So a line containing at least 2 points, okay? Oh, that's the statement. A line contains at least 2 points. Okay, so I mean it's sort of something we already knew. Did you know that line contains at least 2 points?
Yeah.
Okay. Why didn't they say just 1 point? Because doesn't a line contain 1 point also? Why do they say this? A line contains at least 2 points. Why don't they say, doesn't the line contain like 1 million points? Why at least 2? Where are they coming up with this at least 2 thing? Okay, how about William? Say it again. Oh, but line does contain 8 points, doesn't it? Why do you suppose they use this word, a line contains at least 2 points? Why not say, oh, line contains at least 1 point? Doesn't a line contain at least 1 point? Right? Line is made up of millions of points, right? Infinitely many. Why do you suppose they use this word here? Ryan, what do you think?
No, if it was only one, then they could be talking about like range.
It could be array. Not quite. What? Okay, how about Andrea? Did you want to say?
So that like it shows where the line goes. Like, because if there's only 1 point, the line can go from the point at any angle.
Exactly. If there's exactly you got it right. What she saying? Did you all hear what she said? If you just had a 1 point, it could be any lines, right? It could be right. You could be talking about 1 million, right? Infinitely many lines. If I have a particular line, right? If I have 2 points, how many lines will go through those 2 points? Exactly 1 line. So a line, 1 line, right, contains at least 2 points. Okay, does that make sense? So if I want to describe a line, you would need 2 points to describe that line, wouldn't you? If you just had 1 point, you could be talking about millions, right? Infinitely many lines. Very good. Exactly what it is. So this is fact, right? We take it without proof, right? We understand this is to be true. A line must contain at least 2 points. And this postulate has many parts. That was first part. Second part is this. A plane contains at least 3 points, and it's missing something, and you have to add something. Because if you just say it this way, it's not complete. So anybody know what words should go afterwards? A plane contains at least 3 points. Yeah. Coplanar. It's actually not all in one line. In other words, you could actually replace that with anybody. I think somebody said it already. What could I have said? Yes, sir. Yeah, they have to be non-collinear. Why is this statement? Why is it that we have to say a plane contains at least 3 points that are non? Yeah.
If they were all in one line, it would just be a line.
Yeah, if they're all in one line, it could be just a line. Also, how many planes could go through those collinear point? Infinitely many. So if I'm talking about a particular plane, right? We need at least 3 points. Okay, does that make sense? So if I leave this out, this statement would not be true. Okay? A plane contains at least 3 points. So if you have a plane, you know that there's at least 3 non-collinear points. Does that make sense? Okay. What about this? This is sort of the same idea. Now, so like I said, this first postulate has 3 parts. Space contains at least 4 points. But you have to add something to this. If you have space, it has to have at least 4 points that are yeah. In other words, not all in one plane. What is space? This 3-dimensional space that we're living in. That's what we're talking about. Remember, we define space. Space. How do we define space? We said space is set of all points. Remember? Okay. So, the space that we're living in, this 3-dimensional space. Okay. If you have space, it has to contain at least 4 points. Okay. Not all in one plane. Okay. By the way, what does at least mean? More than? There could be. What's the smallest possible numbers you could have? No. Space contains at least 4 points, right? So you could have one set of 4 non-coplanar points, right? Could you have 2?
No. Yeah.
But is it guaranteed?
It doesn't have to, but it can.
Right. It doesn't have to, but it can be. You're right. Okay. But it's saying, like, if I say I have at least $20, right? How much do I have?
20.
Could I have $1 million? Well, that's impossible. But yeah, but all you know is I could have more. But I have at least what? $20. Does that make sense? Right? Is it possible then I have $19? No, that's not possible. Because I said I have at least $20. Does that make sense? Hmm? Oh, okay, well, hopefully I'm not lying. So this is, like I said, postulate 6, that's not the important part, okay? You don't have to even write that. So that first postulate, it has three parts. This one, it's just a statement by itself. So what do you think will go, there's a word that's missing. Through any 2 points, there is exactly one, yes, line is correct. And as you can see, it's sort of related to what we just talked about in terms of lines, the previous. Okay, so I'll give you time to write. Here comes the next postulate. This will be postulate, this is 7. Okay, through any 3 points. So look what it says. I even highlighted this. Think about this. Through any 3 points. So can these 3 points be collinear?
Yes.
Can they be non-collinear? Yeah, it says, because it says through any 3 points, right? 3 points are either collinear or non-collinear. There is something, one plane. What do you think should go in there? And think about this also. And through any 3 non-collinear points. I'm sorry, is it frozen? Here, is this better? Sorry, okay. So this will be, I think, 7. Through any 3 points, there is blank one plane. And through any 3 non-collinear points, there's blank one plane. Think about, as a group, remember your group?
Wait, is this 6 or 7?
Who could answer that? Look at the one right before it. See what it says.
Well, I didn't know if it was still part
But like I said, that's not important. Oh, it's not part of it. Sure. So what do you guys think? Go ahead. Think about this as a group. What word should go in there to make this statement true? I'll give you time. All right, now I'll move it down for you guys. Okay. There. Are you guys happy now? Okay. You good?
It says any point. Could it be a line?
So why do you suppose? Okay, first of all, it says through any 3 points. Now, if you have 3 points, any points, there is there only one plane that could go through those 3 points? But could it be one? When would it be one? Only one plane. If the points are non-collinear, right? When would you have more than one plane that could go through those? If the points are, so what word do you think will go in there so that this statement will be true? Through any 3 points, there is something, 1 point. It could be one or million, right? Or infinitely many. Say it again. How many people agree with that? How many people have that one? You are correct. It is at least.
That's 2 words.
I did?
Yeah.
Well, hey, at least it's not one word. Oh, I meant 2 words. Alright. Okay, my bad. Alright. I didn't know it was okay, at least. Well, I didn't 2 words. And okay, then fine. The last one is 1 word. Then okay, I'll give you guys the chance. The last one, and through any 3 non-collinear points there is, what do you think? 1 word. What do you think? Huh? Only? Okay, anybody else? Exactly. Anybody else? They all mean the same thing. Anybody? Yeah. Huh? What did you? Okay. So you guys are correct. So it is at least and exactly is correct. Sorry, I should have said 2 words. My bad. I should write this for next time. 2 words. Okay, 1. Fine. My bad. Okay, I'll give you another. But do you guys agree? Do you understand what we're trying to say? Does this make sense? Can you believe these statements? Okay, these are postulates. We don't prove them or anything like that. We take them as truth, but it should really make sense to us. It should be something very intuitive, right? Okay, let's move on. Okay, what about this? If 2 points are in a plane, then the line that contains the point is. What do you think? It's not one word, by the way. If 2 points are in a plane, then the line that contains the point is what? What can you tell me about the line that contains 2 points? What's always going to be true? One person. What do you think, sir?
The line that contains the points is in the plane.
It's got to be in that plane. Can it come out of that plane? Is that possible? No. So exactly right. Even though it seems sort of obvious, that's what this statement, true statement, this postulate is. Okay. So imagine, right, on a piece of paper, you point to right dot, and then you connect it. Right. Look at that line. That line better be in that paper. Right. Can it come out of that paper? No, of course not. Okay. So. Well, imagine that line. That paper is a plane, and plane also extends forever. Does that make sense? Okay, so keep that in mind. Good. All right. So write this down. Okay, then who can fill in this blank? This one is rather straightforward. If 2 planes intersect. Okay. Now, when we say 2 planes, we all know what this means, right? Yeah, 2 different planes. If 2 different planes intersect, then their intersection is blank. Yes. One person knows. How about Lauren? Yeah, exactly. Any question? So long. So fill that in there.
Wait, what?
A line. Okay.
How many postulates? Oh, I do.
Yeah. When the 2 planes intersect, okay, the intersection is a line, because we're saying 2 different planes, right? When we say 2 planes. Okay. May I move on? Now we're done. For this section. We're done with all the postulates. We talk about many.
Now the theorems.
Now you're right. Now the theorems. So it is important. Important statements that are proved are called theorems. Okay, so now we're going to talk about our first theorem. Okay, let me just wait. Let me move it up for you. Okay, so I'll abbreviate theorem as THM if you don't mind. Oh, go back up. Okay, hold on. Here we go, guys. Here's our first theorem. It says, if two lines intersect, then they intersect in exactly one point. And of course, we're gonna have to prove this. We'll do that at the end if we have time, but it's actually easy to prove this one. Because when you prove theorem, guess what we're gonna have to use? Anybody have any? Postulates, right? All the statements that we take them as truth, and all the theorems that we actually proved. How many theorems have we proved before? None. So we can't really use any theorems yet. But with this theorem, since we haven't proved any theorems, we're going to use postulates. Anyway, write this down. But does this make sense? If two lines intersect, then they intersect in exactly one point, right? It makes sense, right? Because when we say two lines, what do we mean by this? We mean two different. Exactly right. Okay, write it down. So good. I like how people are actually asking themselves what if question, right? That's exactly what I want you to be thinking about, right? Can you think of any other case where this isn't true? Because if it isn't true, they have actually, the book has made a big mistake, right? Do you think they did? No. So what do you think? Then what can you conclude? If you think this is false and you know that book really it lists like these theorems, they don't make mistakes. So what do you think is happening? That means you are not understanding the theorem correctly. Okay, so that's what you have to go with. Okay, now, what sort of questions do you have? You had what if. What do you mean? What if what? If
Well, what if one line is intersecting on the same line? Like, they're basically the same line.
Good. So I like you. This is great because I want you to be thinking about this. Okay, I don't want you to just memorize it without really understanding and thinking about it. What if the two lines are same exact line? Then you don't get a point as the intersection. Then the intersection is that whole line, isn't
What
it?
if they say two lines?
That's exactly right. Remember when we talk about what do we mean by two lines? Two different lines. So they cannot be the same exact line. Does that make sense? Do you see why we went through all that stuff really to talk about what do they really mean? Right? There's hidden meaning behind them. Hold on, you guys okay?
It's like if two lines are like the same thing, then it's only one line. It's not like
Exactly. So you could argue it that way, but but you could see another person's idea, because two lines that looked exactly like could have equation that may not look the same. You know what I mean? You guys remember slope-intercept form, standard form. So that they could be talking about that. You know what I mean? So yeah, it's a good thing that we clarify this in the beginning, isn't that right? Because otherwise we could be confused with this one. So please, when you have these theorems and things like that, and you read these theorems, this is important, and you think, wait a minute. I could see another possible way for this to be false, right? I could see, by the way, what do you call that? An example that you see as a, you could see an example that makes this thing false. What do you call that example? Anybody know what that's called? It starts with C. So if you have a theorem and you see this example where it shows that this statement is false, what's that called? Yes. Oh, what's that called? It starts with C. Yeah, anybody? Counterexample. If you see a counterexample for a theorem, guess what? Does that mean the theorem is false, or does that mean you're not understanding the theorem correctly? Yeah, you're not understanding the theorem correctly. Does that make sense? This is important to know. Okay. By the way, what if I have this? Here. I can see your time. Oh, this is, yeah. See? You see that there are two intersections, but are these two things lines? No. Okay, you have to have lines. These are curves, okay? So please, if you see other sort of counterexamples, that means you're not understanding the theorem correctly. Okay? Here we go. Second theorem. Again, is it important to remember theorem 1.2? No. Okay, that's not important. This doesn't have a name, so you have to actually remember the statement. But these actually make sense, hopefully. Through a line and a point. Not in that line. Not in the line. So through a line and a point, not in that line. There is something. Through a line and a point, not in the line. There is good things. Yes, sir. Say it again. Array. Well, line. So with a line. No. Because how about no this okay how about Eugene, a plane. Can I just say a plane?
No, exactly.
What exactly? One plane is exactly right. So you have to. When we say exactly one, there's just one, right? So this is sort of saying, like, if the points are, you could actually think of this as three non-collinear points, right? Through three non-collinear points, there's exactly one plane. It's sort of same thing here. But this saying is a little bit different. It's actually going a little further. So if you have a line, and if you have a point that is, this is important. It is not in that line. Because if it was in that line, could you say there is exactly one plane?
No.
No. What would you say?
There
There will be infinitely many planes, right? Do you see why we need there is exactly one plane? It's because you have a line and a point that is not outside of this line. Which postulate does this sound familiar? I want you to look through your notes. There's a postulate that sounds similar to this. Charlie, what do you see?
Postulate 7.
Can you read it for us?
For any 3 points, there is at least one plane.
Okay. So it is similar, but do you see how it's not the same thing here? Okay, good. Does that make sense? All right, let's move on. So Charlie mentioned that that last term we talked about is similar to this term, but actually I want you to focus on the second part. Through any 3 non-collinear points. You told me it's similar to the first part of postulate 7, but actually isn't it more similar to the second part? Because it says through any 3 non-collinear points, there's exactly one plane. Now, how are they saying this a little bit differently in this term? Yes?
They took like 2 of the non-collinear points and made them a line.
Exactly. They took the 2 of the non-collinear points and made it into a line, and then a point, of course, outside, right? Do you see they're similar but not so, they're not the same, right, statement. So theorems, you will find as many times as they will kind of tweak these postulates, even though it may seem very obvious, but then it becomes a theorem, okay, once they do that. But they mean the same thing, right? I mean, they do describe the really similar thing, not the same, similar situation. Very good. So if you have 3 non-collinear points, right, then there's exactly one plane. You would say then it's because of this postulate. But if you happen to have a line that has a point outside of this line, right, there's exactly one plane because of that, then you would use that theorem. Do you see the difference? Do you see the different situation here? Here you're talking about 3 non-collinear points. The theorem is talking about a line and a point outside the line. And I know that in our head it's the same thing, really, right? But you see there's a subtle difference, okay? Let's look at our third theorem. If 2 lines intersect, then exactly one plane contains D. Of course, we need something there. Think about what needs to go after so that this makes sense. And this is a little bit similar to one of the postulates we talked about, but not exactly. So if 2 lines intersect, then exactly one plane contains the. Anyone have any guess? I guess you could say many different things, but in this, 2 people here, 3. Okay. How about Akila? Oh, then exactly one plane contains a point of intersection. Well, when the 2 lines intersect, you get a point, right? How many planes could go through that point of intersection? Infinitely many, right? But they say one plane, so it wouldn't be the intersection. You see what I mean? Because if you have a point, there could be infinitely many planes that could go. But we're talking about just one plane. What can you say about this one plane? One person's here? Have any idea? Yes, sir. What do you think?
That exactly one plane contains the intersection.
Intersection. So intersection of 2 lines is a point. So would it be true then to say that intersection, that point, there
Well, I
should,
mean the 2 lines.
exactly right. So you meant the 2 lines, right? It contains the line, right? That's what should go. So if 2 lines intersect, then exactly one plane contains both of those 2 lines. Could you have 2 planes that contains both of these 2 lines? No. Right? There has to be exactly one. Would you not agree? Does this make sense?
Yeah.
Of course, we're going to be proving these. Some of them we'll prove in class. Some of them you'll prove it at home as your homework, okay? But Okay, let's move on. Does this make sense though, this statement? Right? Okay, so I want you to be aware of when we say exactly one, it means same as one and only one. Okay, so sometimes they may replace these words with these sort of things. Okay, so please be aware. Also, some of the theorems states at a point of intersection exists. Okay, when they say exists, you could also think of this as there's at least one. Okay, so please be aware of that. It makes sense, right? If something exists, then there's at least one. Okay, so you're guaranteed to have one, but there could be more. Does that make sense? Okay. When something exists, that means there's at least one. Also, if they say, do you guys need more time? Okay, you're still writing. Let me wait. Okay. And this also. If I say something is unique, okay, so the point of intersection is unique, that means no more than one such point exists. There's exactly only one point, right? Okay. So please, so do you see the difference between the exist and unique? When we say exist, there could be, you're guaranteed to have one, but there could be more. But when I say unique, what does that mean? There's exactly only one. Do you see the difference?
Yeah.
So good. Write that down. I'll wait. So let's do some exercise. So with your hand, thumb up and down, true or false. Tell me if it's true or false. I'm going to read somebody's statement. Tell me whether it's true or not. Okay, do you understand what I'm saying here? All right, here we go. So knowing all these things, now we're going to be proving these things soon. Okay, so don't worry about them. Okay, so didn't we say theorems are statements that we got to prove, right? We haven't proved any of them. Okay, we'll be doing this soon. Okay, so anyway, but tell me whether the statement that I'm reading is true or false. A given triangle can lie in a more than one plane. True or false? A given triangle can lie in a more than one plane. Okay, I want 100% participation here. Okay. Yeah, you can't do thumb up and down together. This is false. Can somebody show me why this is false? A given triangle can lie in a more than, using one of the theorems or the postulate we talked about will be actually excellent. Anybody see which postulate tells us this is false or theorem? You could look at your notes, that's fine. You don't have to. Who haven't I called today? These are people that I already called. Why is this false, guys? If you have a triangle, why can't it not lie on more than one plane? Why does it have to lie in one plane? In other words, I'm saying this. Yes, sir. How about Ryan?
I will postulate, but that is given. It's like given triangle.
No. When I say given triangle, I'm saying if I give you a triangle, why can't that triangle, right, not be on a more than one plane? Why is it that that triangle has to be in one plane only? What postulate or theorem have we learned that states that that's going to be false? Alvin? No, I mean June? Say it again. Through? You're right, I think. Yes. Through any three non-collinear points, there's exactly one plane. Does that make sense? So it's sort of saying the similar thing here, but I'm giving you a triangle. Do you see the difference? Okay, let's look at you're right. So any question on that? Does that make sense? Do you see why it's false? Next, any 2 points are collinear. True or false? Any 2 points are collinear. And if it's true, why should it be true? If it's false, why should it be false? Through the stuff that we learned today. How about, okay, I see a lot of people. How about, okay, I see You guys are correct. Daniel, why did you say true? You're right. Yeah, it's because through any 2 points there is exactly one line. You see? You guys agree? Right? Because they're saying through any 2 points they are collinear, right? There is exactly one line. Okay, good. Any 2 points are collinear, right? So there's exactly one line. Okay. The next one. 2 planes can intersect in only one point. True or false? 2 planes can intersect in only one point. Everybody should this should be pretty straightforward. 2 planes intersect in exactly one point. True or false? Yeah, we did, right? Good. If you remember, you should know why. Yeah. This is. You're saying this is true? Okay. Okay. This is false. Okay, you got a lot of you are correct. Why is this false? How about Eugene? Why is this false? Exactly. When we just talked about this is true statement. When 2 planes intersect, it's not a point, right? It's a line. Very good. What about this? 2 lines can intersect in 2 points. 2 lines can intersect in 2 points.
You're saying can or can't?
Can. C-A-N. Can. 2 lines can intersect in 2 points. The answer is true or false? False. This is false. Why not? We just talked. This is easy. How about Noah? What did you think?
If 2 lines intersect, then they intersect in exactly one.
You got it. That's exactly. Let's move on. Okay. A postulate is a statement assumed to be true without proof. True or false? A postulate is a statement assumed to be true without proof. Good. This is true, right? I told you. That's what about this? The phrase exactly one has the same meaning as the phrase one and only one. Exactly one has the same meaning as one and only one. This is true. Sort of reviewing what we just talked about. Didn't we just say, okay. 3 points determine a plane. What's it mean to determine a plane? It makes a plane, okay. So 3 points determine a plane. True or false? Okay. Watch what I said. 3 planes determine a plane. I didn't say planes. 3 planes determine a plane. True or false? Jesse, what do you think? I'm not saying. Huh? True. Why do you say true? Oh, so if you have 3, really? Which one?
Through any 3 points, there is at least one point through.
Good. There's at least one. Am I saying at least one? I said 3 points determine a plane. So what I'm.
And in addition to that part of it, there's and through any non-collinear points, there is exactly.
So look what I'm reading. 3 points. Have I mentioned anything about them being non-collinear or collinear? So watch this. This is where people get it wrong here. 3 points determine a plane. This statement is false. Why is this false? I want you to talk this amongst your group. Why is this false? Go ahead. I'll give you time. Why is this statement false? All right. So, Jesse, do you think that statement is still true? Why not? Why is it false? You're right.
If they're collinear, then a loss of the
Exactly right. They didn't say anything about the 3 points. They could be collinear or non-collinear. If they're collinear, you're right. You could be infinitely many planes could go through those points. If they're non-collinear, yeah, there will be exactly one. But that's not what they're saying. They just said any 3 points, correct? So the statement is false. 3 points determine a plane is false, okay? It could determine more than one plane, right? Because if they're collinear. Good. So you gotta listen really carefully here. Through any 2 points, there's exactly one plane. How about this? Through any 2 points, there is exactly one plane. True or false? This is obviously false. How many? If you have 2 points, right? You get a line, right? How many planes could go through those 2 points? Infinitely many. That's why. Okay, last one. Through a line and a point, not on the line, there is one and only one plane. Let me read it again. Through a line and a point not on the line, there is one and only one plane. Does this sound familiar?
Yes.
Yes, this is the same exact statement we just, true or false? True. Guys, that was a theorem that we just talked about, wasn't it? Wasn't it the last theorem? Through a line and a point not on the line, there's one and only one plane. What does one and only one plane mean? The same as? Exactly one. Okay, any question? Does this make sense?
Yes.
Yes.
Perfect.